Were there any questions on the homework that I just passed out? Right, I think hopefully, if my comments are illegible, just let me know. Kind of went over what I thought were the big errors. There wasn't a very strong correlation between the grade on the first homework and the grade on this one. So, pass that to you. There were only a couple, I think only one or two people who did really well on both, and one or two people who did really poorly on both. Everyone else seemed to be
somewhere in the middle.
Well, the correlation was if you did mediocre on the first one, there was a lot of mediocre on the second one. But people who did really well in the first didn't do well in the second, and the other way around. It seemed a little odd. Okay, so are there questions on the homework that's due Wednesday? Yeah.
This isn't a question on the homework, but I think it's the 13th today.
Yeah, it is.
Is it? Yeah. Oh. Okay. Yeah. You know, I'm perpetually a day off on the numbers because the calendar on the surface is wrong.
Don't you have a date function on your watch, though?
I'm not wearing a watch. And I've been wearing one without a calendar. So I just, when I have a habit of just looking at for some reason it won't auto-update, and when I change it and I restart it, it goes back to the wrong. And I don't have appropriate administrative privileges to override the. It's horrible.
Sounds foolish.
Okay, yeah. So I'll fix that. So, there were no questions on the homework? No. Really? Not even the perplexing one about the Young's modulus? I mean, the Poisson's ratio?
Maybe we can go over that one. Since you're going to suggest it.
So I was having problems with 4.2 as far as where they show the dashpot model.
Okay.
I've never really understood the dashpot, but
Okay, so we'll jump to that one in a second then.
okay.
So, so 3.2. Okay. So who feels confident in their answer for that?
I have the explanation, but
Okay.
exact answer I don't know. It will be Young's module. Poisson's ratio is 0.5 means volume is constant.
Yeah.
So for polymers, the chains are tangled with each other and coiled. So when you stretch, this chains got elongated, and until all the chains fully elongate, the volume will be constant. After that, if you stretch, then atomic bonds will get stretched. It is the similar thing of metals. At that time, volume is not constant. So because of that, Poisson's ratio will start to fall.
Okay. So that's the underlying materials physics, right? So how do we come up with a mathematical? Right. So Poisson's ratio inherently is a small strain elasticity approximation, right? So there's a relationship between shear modulus and NKT, right? The number, Boltzmann's constant, and the temperature, right? And if you look in the notes where we talk about that, how we relate that parameter to the shear modulus through a small strain approximation, look at where that starts to fall, to break down, right? And when you pull it, and you'll come up with So it's really this notion that Poisson's ratio is a small strain idea, right? So if you have a stretch ratios, right? If you don't force your stretch ratios to be volume conserving, right? So instead of just having one, you'll have lambda 1 and lambda 2, and I've got something to write on. So normally what we did was said lambda 1 equals lambda 2 equals lambda 3. Or, no, sorry. We have lambda 1, lambda 2, lambda 3 has to equal 1. Right? And so then that gives us lambda 1, lambda 2 squared, because lambda 2 and lambda 3 are equals 1. Right? So lambda 1 equals 1 over lambda 2 squared. Or lambda 2 is 1 over the square root of lambda 1, right? So we have this relationship. But if you don't force this to be true, and you go through that same analysis that we did in the notes, instead of just in terms of lambda, do it in terms of lambda 1 and lambda 2, right? And Poisson's ratio is the ratio between these, basically. And you can see that where.
So ratio between these strains ratios or the actual strains?
Yeah.
So
But what's the definition of Poisson's ratio is?
yeah, it's strain versus strain. So this is 1 plus strain, right? E lambda is equal to 1 plus E.
Yeah. Lambda is equal to 1 plus the small strain.
Yeah, so Poisson's ratio is E versus E. So,
Yeah.
so lambda versus lambda.
Yes, it's not identically. Conceptually, right? Someone has to keep me honest. Thank you. Right, but the idea is just play with the relationships a little bit, and you'll see how it falls out. And it's pretty large. If I remember correctly, it's like a ratio. It's like 800% or something ridiculous like that. So it's a pretty big stretch. So the other elasticity ones, the other rubber elasticity one should be pretty straightforward. Okay, so then 4.2. So is it a conceptual thing of how a dash pot works?
Yeah.
Okay.
Yeah.
So
General thoughts.
okay. So are you familiar with the steer dampener on a motorcycle?
Like the front spring.
No, not the spring. Okay,
Yeah.
but imagine you have a hydraulic cylinder, right? Right. So here's an inlet. Right. And then you've got a piston here that has force on it, right? An increase in pressure here means an increase in force on this piston, right? So it's a standard hydraulic thing. If I move the piston in, right, I increase the pressure here, I can flow the fluid out, right? Now imagine instead of a pump providing a pressure here, there's a couple different ways we can imagine this. Imagine we have a small orifice here that will let fluid out, but only at a small rate, right? So if I put a force here instead of an inlet, it becomes an outlet, right? Imagine I put a force here. I increase my pressure in the dash pot, right? But then over time, fluid leaks out and my pressure decreases, right? So it delays, it has the effect of delaying the motion, right, for a given force. Now in practice, I mean, it's kind of a common engineering device. What you would do is you would make this a solid bottom, you would have a top here, and you would have a couple small holes in this piston so that the fluid would flow from one side to the other slowly, right? And these are useful in dynamic systems because they can damp out unwanted oscillations, right? Because there's a time response. Or you can make hydraulic units with tapered, right? You've got a larger hole here, and you've got this tapered piston, so that initially you get a lot of motion, but then the fluid, you make the hole smaller and smaller, so it damps things out, right? So that's conceptually what a dash pod is, right? So if you look at the standard linear model, right? We've got a dash pot and a spring. So if you look at what's going to happen if I apply a force here, at time, instantly when I apply the force, this spring stretches. Right? This spring can't stretch immediately because it's held in check by the dash pot. But over time, at a constant force, the tension in this spring will cause the dash pot to move. Right? This spring will stretch. Right? And then when I release the force, this spring collapses all the way, but this spring here will slowly move will resist against the dash pot and move it back to its original position. You can always think about this in terms of like a RC circuits, right? If you remember from your electronics, right? Right, and so basically, what you want to do for this question is just work through. You've got the differential equations that describe the Voigt and the Maxwell, right? So you want to basically work through that same process and solve this system for the relaxation time. Right? So we can, has anyone gone through this exercise yet? Has anyone completed this? So we can work through that in some groups today, right? There's this question and another one that I think would be good. Did someone say they had a question with 4.4? 4.3 I removed, right? So hopefully, does everyone get the announcements when I change the assignment? Right here, supposed to come through. Okay. Hopefully, no one panicked when they saw a change in the assignment while I added more. Right, 4.4 is basically very similar to the exercise that we did in class. Right, so there's one more. Find my where I have it written down. Okay. So real fast, the other problem that I gave out. Right. It should be pretty straightforward. So I guess we can work that out on take 30 seconds and show that on Wednesday. So everyone prepare your solution for that for Wednesday. Right? But the main idea is that it's a relaxation test, right? So your strain in your bolt is constant. Right? And the strain when you retighten at 24 hours, right, is going to be, right, because it's linear viscoelastic, I can add all my loads together, right? So my strain at 24 hours, right, is going to be my, I'm going to have a force, whatever force I have in my bolt left over at 24 hours, plus the 1,000, right? That would be from the Boltzmann superposition. That's completely equivalent to me to just adding that adding that as an initial load. Right? So, okay, so we'll see everyone on Wednesday then.